Assalamualaikum. Hello everyone. My name is Jihadtsany from the Civil Engineering Department, Diponegoro University. On this occasion, I will present the assessment of BIM. I happen to get a topic implementation of BIM or Building Information Modeling in the architectural and engineering. So let's start the discussion time. In 40 and 52, Renaissance architect Lion Bastida Albert, in his Architectura at 90 and 87, the 10th book of architecture, distinction architectural design from construction by proposing that the essence of design lie in the thought process associated with conveying line on paper. His goal was to differentiate the intellectual task of design from the craft of construction. Prior to Alberti in the first century before century, Vitruvius in his 10 books of architecture discussed the value in using plans, elevation, and perspective to convey design intent. Throughout architectural history, drawing has been the dominant mode of representation and fundamental to its self-identification. Even now, contemporary writers critique how different architects use drawing in sketches to enhance their thinking and creative work. The extent of Tanhanor tradition is further apparent in the way that computers were first adopted in architecture, as CAD, computer-aided designs and drafting. Because of his story, Building Information Modeling, or BIM, is revolutionary in the way it transforms architectural representation by replacing drawing with 3D virtual building models. It changes the way that a representation is constructed, fundamentally changing the line by line layout of out and the thought process that go with it. Learning the truth of BIM is just the first level step, leading to how design concepts are created, refined, and evaluated. This change suggests my thinking regarding the degree the designer of generate conceptually in a designer head and record internal dialogue between the designer and the external representation, or emerge through a set of designs documents. They provide a scaffold for different specialists to process or alter. The point is that the current intellectual task is being transformed along with the representation. Outline of traditional architectural surface. Physi- First is feasibility study, non-spatial quantitative and textual project specification, dealing primarily with cash flow function of income generation. Associates areas and required equipment include initial cost estimation, may overlap and iterate with pre-designs, may overlap and interact with production or economic planning. And second is pre-designs, is fixed space and functionality requirement, pricing and possible expansion requirements, set and context issues, building code and zoning constraint, may also include update cost estimate based on add information. And third is schematic designs, is a preliminary project designs with building plans, showing how the pre-design program is released. Massing model of building set and early rendering of concept, identify as candidate, material and finishes, and identify as a building subsystem by system type. And four is design development, is detailed floor plans including all major construction system like a walls, facades, floor, and all systems, structural, foundation, lighting, mechanical, electronical, communication, and safety acoustic, etc. With general details, material, angle, finishes, site drainage system, and landscaping. And then construction detailing is a detailed plans for demolition, site preparation, grading specification of system and materials, member and component sizing and connection specification for various system, test and acceptance criteria for major system, all sizes, blockouts, and connection required for inter-system integration. And then construction review is a coordination of detail, review of layouts, material selection, and review change as required when build conditions are not as expected or due to errors. And now, because of this story, BIM or Building Information Modeling is a transformational path to transfer ancient architectural methods into visual modeling in 3D. Coordination and collaboration involves different levels of communication platform use. BIM is able to significantly benefit from this because it is able to provide an integrated digital platform. And we can see it here, the new communication capabilities provide new opportunities for improving what designers produce. It potentially supports automatic interface with analysis and simulation programs that provide feedback to the design development process. Earlier, coordination with fabricator through building model is expanding the level of coordination with construction. This change will in turn affect the way designers think and processes they undertake. These changes have only just begun, but even in this early stage, BIM is redistributing the time and effort designers spend in different phases of designs. And next, you can see a scope of design service at here. Design is the activity where a major part of the information about a project is initially defined. Antitrust law prohibits the AEI publishing standard fee structure, but the earlier traditional contract for architectural service suggests a payment schedule, and thus the distribution or efforts to be 50% for schematic design, 30% for design development, and 55% construction document and project supervision at AIA at 90 and 94. This distribution reflects the weight traditionally required for the production of construction drawing. We can see at the figure, due to its ability to automate standard form of detailing, BIM significantly reduces the amount of time required for producing construction documents. It illustrates the general relationship between design effort and time, indicating how effort is traditionally distributed. At line 3, we can see at line 3 at here, and how it can be redistributed as a result of BIM at line 4. This revision aligns effort more closely with the value of decisions made during the design and build process. We can see at line 1. And the growth in the cost of making change within the project lifetime at line 2. The chart emphasizes the impact of early design decision on the overall functionality, cost, and benefit of building project. The fee structure in some projects is already changing to reflect the value decision made during schematic design and the decreased effort required for producing construction document. The change in distribution of effort also makes assumptions about the delivery method and contracting. Here we explore some of the implications. In the world of architecture, several design development software have been known as SketchUp, as Rhinoceros, and Bonsai 3D. These tools only focus on creating geometric design shapes, but do not have building type object and the behavior of material object. To that, there are no tools to support the full scope of conceptual design, either for design exploration and development or for product delivery at the schematic design level service. And after passing the conceptual designs by architecture, then a building project requires detailed specification, carry out an overall design process through multidisciplinary collaboration that is able to provide direct service and save work costs by eliminating repetitive work and making drawing so that they are more productive. And range of often used design technical service. First is financial and cash flow analysis. Second, analysis of primary function, including service in hospital, rest home, airports, restaurant, convention center, parking garages, theater complexes, and support site planning, including parking, drainage, and roadway. Designs and analysis are simulation of all building system, including structure, mechanical and air handling system, emergency alarm or control system, lighting, acoustic, curtain wall system, energy conservation and air quality, vertical and horizontal circulation, security, and then cost estimation. Next, accessibility assessment. Next, landscaping, fountains, and painting, and external building cleaning and maintenance, and the last is external lighting and signage. And then is an effective interface between a BIM authoring tool and an analysis application. As design development process, detail concerning the building's various system must be determined in order to validate earlier estimate and to specify the system for bidding, fabrication, and installation. This detailing involves a wide range of technical information. All buildings must satisfy structural, environmental conditioning, freshwater distribution and wastewater removal, fire retardants, electrical or other power distribution, communication, and other basic functions. While each of these capabilities and the system required to support them may have been identified earlier, their specification for conformance to codes, certification, and client objective require more detailed definition. In addition, the space in a building are also system of circulation and access, system or organizational function supported by the spatial configuration. Tools for analysis of the system are also coming into use. Yet, apart from the benefit of BIMs, provide to overall design process through multidisciplinary collaboration. BIM can provide direct and localized economic benefit for engineers by eliminating rework and making drawing production more productive. Significant effort is required to prepare the data sets needed to run analysis. With appropriate BIM interface, a model representing the actual geometry can be used to derive both the analytical model and the drawing set, thus eliminating or highly simplifying preparation of the analysis input datasets. And then an effective interface between a BIM authoring tool and analysis application involved at least aspect. First, the assessment of specific attribute and relation in the BIM authoring tool consistent with those required for the analysis. Second, method of compiling an analytical data model that contains appropriate abstraction of building geometry for it to function as a valid and accurate representation of the building for the specific analysis software. The analytical model that is abstract from the physical BIM model will be different for each type of analysis. And third, a mutually supports exchange format for data transfer. Such transfer fields must maintain association between the abstract analysis model and the physical BIM model and include ID information to support incremental updating on both sides of the exchange. These aspects are the core of BIM's fundamental promise to do away with the need for multiple data entire for different analysis applications, allowing the model to be analyzed directly and within very short cycle times. Almost all existing building analysis software tools require instances pre-processing of the model geometry, defining material properties and applying loads. Where BIM tools incorporate these three capabilities. The geometry can be derived directly from the common model. Material property can be assigned automatically for each analysis, and the loading condition for an analysis can be stored, edited, and applied. The way in which structural analysis are handled illustrates this aspect well, because architectural design applications do not generate or represent the structural member in a way that is suitable for performing structural analysis. Some software companies offer separate version of their BIM software to provide these capabilities. And next, we can see a sketch apply style and editing example into a modeling of BIM. BIM tools are capable of incorporating geometries that can be input from general model by architectural modeling, defining material properties for each geometric element and material properties according to building code regulatory requirements to provide accurate data on the volume of material so that it can be used as a more accurate cost estimate. And next, uh, drawing generation is an important BIM protection capability, and it's likely to remain so for some time. At some point, drawings will stop being the design's information or record, and instead the model will become the primary legal and conceptual source of building information. The American Institute of Steel Construction, in its Code of Standard Practice, has adopted contractual text saying that if the structural steel of project is represented by both a model and drawings, the design of record is the model, even when such changes become wet parts. Design frames or record will still need to protect various drawings to fulfill contract requirements, to certify building code requirements for contractor of agricultural estimation, and to serve as the document between designer and contractor. Drawings are used during construction to guide layout and work. General drawing protection development for BIM tools are presented in Chapter 2. With the development of BIM and its report generation capabilities, once the legal restriction on the format of drawing is eliminated, options arise that can further improve the productivity of designs and construction. Already fabricators that have adopted BIM tools are developing new drawing and report generation layout with better server specific purpose. They apply not only to repair bending and builds of material, but also layout drawings that take advantage of the 3D modeling of BIM tools. An aspect BIM research development development of specialized drawings for different fabricator and installer. The mid-term goal is to completely automate the production of drawing from a model by applying predefined templates for drawing layouts. However, a close look at special conditions makes it evident that various special cases areas is in most projects that are themselves so related planning for them all, and preparing template rules is not worth the effort. Just review for completeness and layout of drawing reports prior to release is likely to remain a needed task for the foreseeable future. And one way to indirectly assess the benefit of practicing a technology is the team is able to provide history of changes with the number of requests for information, like RFI, and change order COS. On the projects, then BIM can also predict business improvement through marketing of BIM capabilities by a company. And uh, Designers can approach the development of construction level model in at least three different ways. First, as traditional conference, the designer's building model is a detailed design expressing the intent of the designer and client. In this view, the contractors are expected to develop their own independent construction model and document from scratch. Alternatively, the building model is regarded as a partially detailed model to be further detailed for use in all aspects of construction, planning, and fabrication. In this view, the design model is the starting point for elaboration by the construction team. And third, the design team can collaborate with contractor and fabricator from the beginning, being informed about fabrication issues as they model. The preferred model rather that incorporates fabrication knowledge along with design's intents. The biggest challenge in implementing BIM technology is the internal transition in establishing BIM practice on all HR to adopt new practice. Because BIM is a new IT environment requiring training, system configuration, library and document templates setup, and adoption of design review and approval procedures, often combined with new business practice. This need to be developed incrementally, side by side with existing production method, so that learning problem do not jeopardize the completion of current projects. We encourage preparation of a detailed deployment plan for any firm considering making a change to BIM. Adoption should not be treated as an ad hoc activity. The more grounded the plan is in relation to a company's strategic goal, the more successful adoption is likely to be. The following section address a range of issues to be considered in the deployment plan. Training usually starts with one or a small number of IT specialists that both plan for system configuration and introduce a training program for the rest of the firm. System configuration includes hardware selection, like a BIM tools demand powerful workstation hardware, server setup, plotting and printing configuration, network access, integrating with reporting and project accounting, setup of library, and other company specification system issues. In early projects, so focus on the basic skill needed for modeling build and producing drawing, including incremental definition of object labels and getting the basic done before undertaking more advanced integration efforts. After the basics of project management have been released, the door is open to a variety of expansion for taking advantage of the multiple integration and interoperability benefits that in our. And the greatest challenge in implementing new design technology is the intellectual transition in getting senior design time leaders to adopt new practice. The senior staff often partner have decades of experience with clients, design development procedures, design and construction planning and scheduling, and project management that represent part of the core intellectual property within any successful firm. The challenge is to engage them in the transition in a way that enables them to release both their own expertise and also the new capabilities they beam over. Among the several potentially effectively ways to address this challenge is first, team partner with young beams savvy design staff who can integrate partner knowledge with the new technology. And we can see it here. A second major challenge in any firm will be the change composition of staff with respect to skill, because BIM most directly enhance productivity for design documentation. The proportion of how spend of any project is shifts away from construction documentation. Within a typical practice, a designer's skill in BIM can release the intention and detailing of a project with much less outside drawing or modeling support than was previously required. Detailed material selection and layouts only need to be defined once and can be propagated to all drawings where they will eventually be visible. We can see it here. As a result, the number of junior staff members working on construction documentation will be reduced. A good example of the way in which the workload for a project is shifting in an acceptable practice that has already adopted BIM can be seen in table. This data was reported by a principal architect at a large decision firm at Briggs 2005. While the total labor hours are reduced, the total cost didn't change substantially due to a shift toward more experienced labor staff. Although the need for entire level architect is reduced, drawing cleanup, model detailing, and integration and coordination of multiple building systems will continue as important and valuable tasks. Among the several potentially effective ways to address this challenge, first is we can see some solutions that can be done to overcome this problem are first, construction projects can partner with young design staff who understand BIM, who can integrate their knowledge with the new technologies. And next, provide one-on-one training 1 day a week or on a similar schedule. We can train employees of skill. And next, host a courage for design teams that include training for partners in a relaxed offset location. And we can visit of companies that have made the transition to BIM or attend live seminar and web-based seminar. And similar transition issues exist with other senior staff, such as project manager, and similar method may be used to facilitate their transition. No method is guaranteed. The transition of a design organization is largely cultural. Through their actions, supports, and expression of values, senior associates communicate their attitude toward new technology to the junior members within the organization. A second layer in any design firm will be the change composition of staff with respect to skill because BIM most directly enhances productivity for design documentation. The proportion of hours spent on any project shift away from construction documentation. Within a typical practice, a designer skill in BIM can release the intention and detailing for a project with much less outset drawing of modeling support that was previously required. Because material selection and layout only needs to be defined once and can be propagated to a drawing where they will eventually be visible. As a result, the number of junior staff members working on construction documentation will be reduced. BIM technology has new associated overhead costs beyond that of software investment. As BIMs already know, system management, often under the management of the Chief Information Officer or CIO, has become a crucial support function for most firms. IT dependency expands as it supports greater productivity in the same way the electricity has become a necessity for most kinds of work. Being inevitable adds to the dependency. Two important rules that need to expand for companies such as implementing BIM are first, system integrator. The function will be responsible for setting up exchange method for BIM data with consultant inside and outside the firm. These are corporate or enterprise level responsibility. It also involves setup of libraries and templates for company use. The application may be limited to a single set that are used in every project or a variable set that is selected according to the type of project and the consultant involved. And the second is model manager. While the protocol for version control and managing release are defined and well understood within the drawing document-based world, like whether paper or virtual. Options are different and more open and with BIM. There might be a single master model or a set of federated ones. Sense model or accessibility 24 or 7 reels can potentially be made multiple times a day. As a result, the potential model corruption exists because a project model is a high-value corporate product. Maintaining its data integrity justifies explicit management. The model manager determines the policies to be followed for establishing, read, and updating privilege, for managing consistent work, for coordinating workflow and project level basis, and for managing model consistency across versions. Dealing with model review and release and managing the consistency of models will require special attention until a set of convention becomes standard. A model manager role must be assigned for each project. And last, the implementation of BIM in the construction sector provides insight for young architects and engineers for technological advance in the construction sector. This, of course, provides an improvement for the nation in the era of modernization and provides its own challenge for actors in construction world. And thanks.